So, example, the qualitative observation, a bunch of beautiful round and small, smooth glass marbles are there. You can see that the how many marbles are there? They can say it's a 5 marbles. But when we talk qualitative observation, 5 marbles of 1.5 centimeter diameter each is there. That's a qualitative. But you don't know what is the inside in that marble. So we can say it's a marble, but we don't know what is the inside in that marble. Or sometimes you don't know what kind of material you used to prepare this marble. But it look like marble, that's all. But when we analyze the quantitatively, so we should have to know that what is the amount of silica, SiO2, used to prepare these marbles. Then each and every marble we have analyzed in detail and find out what is the amount of silica available there. In the qualitative, it's a marble and maybe silica is there or not. But in the other case, quantitatively, we should have to know some material available in the marble and what is the amount, exact amount we have to know. Therefore, qualitative analysis, we can say, so what is it? But quantitative analysis is how much, right? So that is there. And in the other case, so sometimes we can say the marble, the material, but generally marbles are there and 5 marbles are there. If we can say like that, it's also how much, or quantitative analysis, right? So when we do the quantitative analysis, whatever the analysis, whether it is a chemical analysis, physical analysis, instrumental analysis, or the microbiological analysis, or the sensor analysis, we have to follow some steps in analysis. There are 1, 2, 3, 4, 5, 6, 7 steps are there you have to follow. And here I am going to tell you that what are the steps and in detail about each and every steps. So let's see what are those. An analysis involves several steps and operations which depends on the particular problem, your expertise, the apparatus or equipment available, and then only the analyst should be involved in every step, right? For example, first of all, we have to know what is the problem, or the particular problem is there. For example, let's see, now we are going to prepare the yogurt, and for the yogurt, we need the inoculum. Or the inoculum, I think you have done those things. However, so you are going to do those in the preservation class. You have to understand what's the problem first. And then, so if you are going to prepare the yogurt out of using milk, if the milk is not good, then you will not be able to prepare the yogurt, right? So therefore, the problem is here, we can say, before we prepare the yogurt, we have to know that whether this milk is good or bad. So here we have to identify that what is the particular problem. Then that means we need not to know that what is the protein content of this yogurt, or what is the fat content of this milk. Likewise, in detail you need not to know, but you have to know that whether this milk is good or bad. There are some tests, so those tests, so you need not to identify the real amount, but qualitatively you should have to know that whether this milk is good or bad. Then the second one is your expertise, right? As I mentioned you yesterday, that your expertise is needed. Let's say now there is some laborer is there in that company, who is doing the washing of or the cleaning in the cleaning service. So his duty is the cleaning all the floor, and every day he has to clean the floor after finishing the production. So if you ask that person to do that experiment, whether he will be able to do it, no, he don't know, because he doesn't know, because he is not an expertise to carry out the experiment. So likewise, the person who handles the problem should be a expertise person in relation to analyze that sample. And also the apparatus or equipment available is very much important, because according to the different equipment you are going to use, or available equipment, you will be able to carry out or follow different steps, right? Therefore, so you have to understand that what is the problem first, and your expertise, whether you are okay to handle this problem or not, or if, then what are the apparatus or equipment available there. Right? Then let's move to the one by one for steps in an analysis. There are, I mentioned that there are 7 steps. The one is the define the problem. The first one is the define the problem. Second, after that, so you have to select a method. After that, you have to find out, obtain a representative sample. Right? Then you have to move to the prepare the sample for analysis. Then perform any necessary chemical separations and perform the measurement, calculate the results and report. So these steps actually we have followed in previous semesters under each and every practical, especially under the food chemistry related one, and also in the other practical too. So first we have to there are some objective. Then under the objective, the problem is the procedure is given. Then obtain a representative sample. Sometimes the demonstrators give the sample to you. If not, the sample is there given in to the workstation. After that, they prepare the sample for analysis. Sometimes if samples are prepared, then it won't be a problem. If not so, you have to prepare the sample. Then perform any necessary chemical separation. But this part actually sometimes you need to distillate the sample. If not so, you have to dissolve the sample in the water. Especially in some cases, you have to dissolve the sample in the water or the another solvent. And this is the necessary chemical separation, no? Or you have to dissolve it, or if not so, you have to do the chemical separation. This section I will tell you in detail later on. Then perform the measurement or get the data and calculate the results and report. That is the normal practice you have follow in during when you do the analysis, right? And then let's see one by one each steps. The first one is define the problem. So when you define the problem, there are factors you have to follow. So what are those factors? What is the problem? What need to be found? Qualitative and or quantitative. Sometimes you have to follow the qualitative test, and then you have to follow the quantitative test. Because then what is the problem? For example, now I'm going to ask some question, because in the face-to-face class even I ask those questions. Therefore, please answer, because your answer is very much important to take this lecture forward. Whatever the answer is okay, but try to give the what do you think about that? So anyone can answer. And what is the problem? Let's see. Now, basically, now tell me any kind of process or the product that you know carry out in the production in the manufacturing company. I think there are some students who have followed, who have done special assignment in the food industries. Anyone can answer. I think you have joined to the qualitative quality assurance lab. Sometimes you have visited there. Therefore, you know some problems are, some analysis are carried out in that companies in their laboratories. Have you remember anything? Anyone can answer? Right. Yes, Sarah? UHT milk production, right? Under the UHT milk production, right? Where did you attended Kosala? Is it Nestle or any other company?
No, my special assignment.
Kosala, your voice is not very clear. Something wrong. Okay, let's see like that. Then, for example, so she need to, in the milk production company, so the dairy-based company, they are going to prepare a cheese, right? So they, in this case, so before before they prepare the cheese, they want to analyze the milk sample or sometimes the UST milk, right? So they want to know that whether the bacterial count of this sample is high or not, or the, let's say, the salmonella amount is there. It's whether it is higher or whether it is salmonella. In the case of salmonella, actually, salmonella is a positive or negative. If salmonella is positive, then whether there is what is the load is not a problem. So you have to think about, if salmonella is there, then you have to reject the sample. Then you need not to go for a quantitative analysis, right? But in the case of total plate count, then if the qualitative total plate count, then you can go for a quantitative analysis and find out whether the amount, what is the amount, and then you can proceed if the amount is low, right? But in the case of salmonella, you can't do it. But in the case of the total imperial count, then you can follow it. In the other case, there are sometimes you may heard some term, it's a histamine. So histamine is normally we have to check in the fish before we export the sample. Then in the histamine content, so here we analyze the qualitative, we don't analyze the qualitative test, but we have to analyze sample for a quantitatively and find out, so what is the amount is there. Because with the sample, with that consignment, you have to send the report to the other country. Therefore, in the case of histamine analysis, you have to do the quantitative analysis, right? Therefore, right. Thank you, Kosala. Right. Therefore, here we have the problem. What we have to analyze the problem or understand whether this one is needed as a qualitative or quantitative. Because sometimes the qualitatives are the plus or the positive or negative. That is enough to proceed the experiment or proceed the manufacturing. So in the other case, let's say for example, in the sugar content of the sample, because so if you want to, now let's see that you are going to prepare the jam, right? When you prepare the jam, definitely you will add sugars. Then if we analyze the sample for presence or absence of sugars, that is a qualitative test, that is a no meaning. Because we have to go for a quantitative test, because we have to, in the label, we have to show that what is the amount of sugars available there. In the other case, even that many sample, the sugar or fat or salt content, you have to analyze, even yogurt, even whatever the milk product. So most of the biscuits, whatever the product, now the signal light is very compulsory. Therefore, they have to analyze those things quantitatively. If without knowing that the quantitative amount, they can't go for a red, green, or yellow. So to mention that one, they have to analyze the sample. Then the next one is what will the information be used for, right? Right. As I mentioned you earlier, and you also mentioned the same, that what will the information be used for? So who will use it? Now let's see this to obtain nutritive value, to determine the functional properties, or the whether to evaluate hygienic values, to evaluate the risk of adulteration, to evaluate the quality of raw material. Likewise, we have to know that why we need to analyze or why we need to get this information. So as I mentioned you earlier, if it is for a signal light, let's say it's for mention in the label. Therefore, we know that what will the information be used for, who will use it. That if we analyze a sample for the sugar content, protein content, fat content, likewise, so then that information you are going to use by the manufacturer to display in the label, right? Then who will use it? The manufacturer is going to use it, as a customer, we also going to use the same information, because before we purchase a sample, we have to check the package. Or before we purchase the product, we have to check it, right? Then manufacturer for labeling purposes, as well as also we use it as a customer. When will it be needed? So for example, in the signal light information, sugar, fat, or oil, when it will be needed? It needed for a final product, not the initial raw material, right? It is needed for a final product. But in the case of yogurt manufacturing, if we are going to check the milk sample, it is needed at the beginning. Manufacturer needed it before they send the milk sample to the production section. Sample mean the milk, whatever the release to the milk to the production section, they need that information. So therefore, when will it be needed? Maybe at the beginning, sometimes maybe as an end product, or sometimes maybe they are during the process. So when will it be needed? That is also very important, because accordingly we should have to know that we have to release the results as soon as possible, right? In the for example, and the other cases. So in that cases, we have to find out the very easy and quick method to get the results, right? When will it be needed? When we define the problem, that is also very important. How accurate and precise does it have to be, right? How accurate and precise does it have to be? That is also important, because sometimes that there is for example, if we are going to use that information for the signal light, it should be very accurate one. Because if you are not going to give the accurate one, sometimes it will come to not the green area, maybe it go to the yellow or red area. Then you can't release the sample to the market. Therefore, and also at the beginning, wherever the place, the accuracy and precision, it is very important. Therefore, you have to think about that. What is the budget? That is also important. So if there are, as I mentioned you earlier, there are a number of methods available to analyze the sample. But we have to think about that why we need this data, as well as what is the budget or what is the money we have to spend for that one. Because sometimes let's say now calcium or the phosphorus determination, we can analyze we can do the phosphorus determination by titrometric method, right? So you are going to do it in the class. And also we can determine the phosphorus by using ICP-MS method. That is a mass spectroscopy method. It's a very expensive and but you can get the very fine data, very accurate data you can get, not like a titrometric method. I will show you later on what's the sensitivity and precision of this data. And therefore, we need not to go for ICP-MS. We need to go for a atomic absorption spectroscopy. Likewise, there are a lot of the high-tech one, but in some cases, so we just need the normal method, titrometric method may be enough. For example, let's see, now we are going to analyze the phosphorus content in the fish sample. So because you know that the fish is having bones, and therefore the phosphorus are there. And definitely phosphorus is available molecule in the fish. Therefore, so the titrating method is enough if you are going to use that the data for your thesis or the research thesis. But you need not to worry about the ICP-MS method. Only age method also available, but you need to worry, right? So likewise, then by using the small budget, small money, you can get the data information. The analyst, the problem solver, should consult with the client to plan a useful and efficient analysis, including how to obtain a useful sample, right? Here, therefore, the final point is the analyst should have to talk with the client. The client is the person who needs the information, and if it is a company, maybe quality assurance section, quality assurance manager, then the analyst should have to discuss with that person and then find out the plan a useful and efficient analysis, including how to obtain a useful sample. And getting the sample also very much important, because some samples are very expensive. Sometimes the samples are very expensive, but in the case of food manufacturing factory company, the samples are not much important. But if you are going to analyze the sample for other purposes, if you are, let's say now you are working in a food analysis company or the analysis company, then so you have to discuss with the client, because sometimes the client need if the sample is very precious, he is not going to give a much amount, just a small amount. Then you have to think about what is the amount you are going to get, and accordingly you have to decide what is the sample, what is the method you are going to use. Therefore, define a problem is very much important. Next one is a select a method. Now, after as mentioned earlier, the sample type is important, right? Whether this sample is a liquid, whether this sample is a semi-solid, whether this sample is a dried sample, or likewise, so you have to know that what is the sample type, whether the sample is a homogeneous or heterogeneous. So I will show you what is the homogeneous and heterogeneous words later on. Then what is the sample type you have to know, right? And then the size of the sample also very important. If for the titometric analysis, you need the much amount of sample. For example, the other one is, let's see, for the protein analysis, you can do in a two method, microkeldal and macrokeldal, right? In the microkeldal, you need a very small sample, very minute sample you can use, but for a macrokeldal method analysis for the protein, you need at least 2 grams of the sample. But for the other one, maybe 0.2 gram of the sample may be enough. Therefore, size of a sample also very important. If you are going to get 0.2 gram of the sample, then you definitely go for a microkeldal method. And if you are getting the more 5 gram sample, then you can go for a macrokeldal method. But both keldal principle is the same. But upon the size of sample, you have to think what is the method you are going to use. And if the client is unable to produce 2 gram of sample or the 10 gram of sample, because you have to replicate, you have to do the analysis. And if the client is unable to give, then if you are having the microkeldal, then you will be all right. But if you don't have the microkeldal equipment, you can't analyze the sample, right? So accordingly, whatever the instrument available in your laboratory, you have to consider that one, as well as accordingly you have to ask the sample. I need such amount of sample from you. You have to tell the client, right? So likewise, the sample type, whether it is a liquid, solid, or semi-solid, and or the powder or the solid means a solid, you can say that it's a bigger particle or smaller particle, likewise. So you have to understand what is the sample type. Size of the sample also very important, and sample preparation, whether sample preparation is needed. So sometimes if you are going to get the semi-solid sample, you can use the sample as it is for the analysis. But in the case of, for example, let's say the protein analysis, in the case of protein analysis, so you need the sample as a dried sample, not a wet sample. So you can use the wet sample even, but normally for the protein analysis, we use the dried sample after removing moisture. Therefore, whether if you are getting the fish sample, so you have to dry it first and remove the moisture, and then you have to take the dried sample for the protein analysis. But if the sample is, let's say, now having a high amount of fat, then if there are fat available then it is disturbing for a protein analysis. Therefore, first you have to remove the fat by distillation method, Soxhlet method. Then after that, you have to take the defatted sample for a protein analysis. So likewise, then you have to follow, first you have to dry the sample, then you have to defat the sample, and then only you have to use that sample for a protein analysis. Right? Then sample preparation also very needed. Then the next one is the concentration and range. Sensitivity is you have to know. So what is the concentration you need to get, and what is the concentration, the range of the concentration. There you have to think about the sensitivity. I will tell you those things in later on, because by giving some data. The other one is the selectivity needed, that is the interferences. Because if you are going to, for example, if you are going to analyze your sample using the spectrophotometric method, you know, for the spectrophotometric method, we basically do is measuring the color intensity. If there are any compound is having is masking that the color or the color complex, masking means that once you add some ingredient or some reagent, the color will be developed there, but another compound available in the same sample make a complex with that the color that the reagent. So once you add the sample, add this reagent to develop the color, another material in the sample is make a complex with that the reagent, and it does not allow to develop the color. Right? Can you understand that situation? Because I will try my best to explain you. So then there are in that cases, so you have to remove the interference first, and then only you can use the reagent to develop the color to determine that whatever the molecule you want to analyze. Right? So the accuracy, the next one is the accuracy and precision needed, and then the tools and instruments available. Accuracy and precision, you know what is it. Then the tools and instruments available, the next one. So whether enough, whatever the spectrophotometry method, if you are going to follow that, whether you have the spectrophotometer. But if you have the colorimeter, you can't determine all the sample by using the colorimeter. That always absorbance you can't take from the colorimeter. You have to go for a spectrophotometer. Therefore, if your laboratory is not having the spectrophotometer, then you can't decide that method. Therefore, tools and instruments available in your laboratory is very much important. The other thing is expertise and the experience. So whether you have expertise to analyze this sample, or whether other person in your lab having the expertise to analyze the sample, as well as whether that person is the experienced person. Because if sometimes when you are doing the research project in the 4th year, you are not an experienced person, but your supervisor basically he's an experienced person. Therefore, if the problem comes, then the when you talk with your supervisors, supervisors advise you, okay, that is happening because of this situation. You have to follow that. You have to avoid that situation. You have to follow these steps. Likewise, that experienced person will give you the information or the how to carry out this experiment. And the other one is the cost. As I mentioned you earlier, so what is the budget you have? Accordingly, you have to do this analysis. Select the method, and the speed very important. If you are going to analyze this sample for, let's say now is the moisture content determination, right? So during the process even, you should have to analyze the sample for a moisture content. Now the process is going on. You should have to know that whether the moisture content is okay in this sample. In that situation, let's say that the sausage manufacturing or whatever thing, in that situation, can you go for normally for moisture content analysis, you can use the oven drying method. For the oven drying method, you have to keep your sample for more than 2 hours in the oven. But you have no time to keep your sample for 2 hours in the oven, in an oven. In such situation, so you have to use the moisture meter. In the case of moisture meter, just you put the sample and switch on the light, switch on switch on the instrument, and it will give the roughly, not the exact moisture content, but you can get some idea about the moisture content by that. Accordingly, you can give that information to the production section. Then production section follow the rest of the thing, right? Or to get the product out. So therefore, the speed is very important, because in some situation you need to digest the sample, and likewise, so it need a longer period. But in some situation, quickly you can get the results. Therefore, that according define the way you define the problem, you have to select a method. Therefore, speed also very important. Does it need to be automated? In some situation, you can get the automated, once you put the sample, just you can get the results, right? So therefore, in such situation, if the process is going on and you are going to analyze the sample as in that moment, then automated method is much important. And quickly, if you can get the results quickly, then it is much better. And if not so, it will take time. And actually, sometimes some points you will not be able to understand in that situation, but later on you can understand. That is the thing Madam mentioned earlier. Likewise, so once you finish after 1/3 of this lectures covered, then come to that point and go through this slide and see whether you can understand this much better than today, right? Next point is, are methods available in the chemical literature? So that is very much important, especially when you do some analysis in your research project, or likewise during your graduate undergrad period. Then you have to follow the chemical literature. That means whether these type of analysis has done by the people earlier. Another scientists, have they done this kind of analysis? Then it may be very supportive for you to finalize your method, right? Before you select the method, sometimes that method is there or written there in the chemical literature or the previous scientific article. If not so, you have to decide design the method by yourself. Especially in the case of when you do the master's or the postgraduate degrees, especially sometimes you may have to define or design the method by yourself. You need not to follow the method, but what have decided, what have written in the article. You have to design the method for yourself. The final one is, are standard method available? So sometimes there are standard methods. For example, American Oil Chemists Society, AOCS, is a very big book, and having, I think, more than 1,000 pages in the small letters, and there the standard methods are available. So you can follow that standard method, and then it's much easy. And in some situation, you need not to follow the standard method, but you have to use your own method, but you have to justify that method is really very correct. And sometimes the Sri Lanka Standard Institute also, they produce some guidelines. And if you are going to take the SLS standard for your product, then you can follow the SLS guideline, and accordingly you have to find out what are the suitable standard method for analysis. So likewise, there are different action you have to take, select a method, right? These factors are important when you consider the selection of a method. So you have to find out or go through these points and checklist with what is the sample type, size of sample, everything come to your mind quickly, right? Once if you are an experienced person, so once you see the sample and understand what you are going to analyze, so you know this is the method I'm going to use. But basically that idea come to your mind, but quickly these points is working in your mind, and then come to the decision. So here I just mentioned that the titometric method, the HPLC, high performance liquid chromatography method, and also the spectroscopy method. This is not the spectroscopy, it is again this one also the chromatogram they use, right? So this is not the high performance liquid chromatography method, and likewise there are many methods later on you can understand. Now here it says that different methods provide a range of precision, sensitivity, selectivity and speed capabilities. Now you can see that they are in the left hand side, some informations are given here, right? You see that these are the methodologies. Gravimetry method, titometry method, potentiometry method, electrogravimetry method, coulometry method, gravimetry on the coulometry, voltammetry and spectrophotometry, fluorometry, atomic spectroscopy, and chromatography, kinetic method. Likewise, there are many methods are available. I think the students who followed that chemistry 2, they have some idea, as well as all the students up to now, they may know about the gravimetry method, titometry method. They basically have followed these things. I think that the potentiometry methods also use some in the chemistry 2, and spectrophotometry, I'm not sure. Have you done the spectrophotometries also, that methods? Have you done, students?
Yes.
Yes, then you know spectrophotometry also you have know. Then chromatography and kinetic methods, have you done? Kinetic methods? No. Chromatography methods? No. But during this program or this course module, you are going to follow these methods also, right? Accordingly, so you can see that what is the comparison of different analytical methods and the approximate range, that the molecular per liter, that if you are going to measure the concentration by the gravimetry method, you can measure 10 to the power minus, that means 1, that means 0.01 to 0.001, that range you can get the accurate results by the gravimetry method. By the titometry method, you can get the 0.01 to 0.0001, that range you can get by the titometry method. When you see the other side, the precision percentage, you can see gravimetry method is a 0.1. You know what is the precision, right? And titometry method is a 0.1 to 1. That means titometry method is much higher precision is given compared to the gravimetry method. When you go to the potentiometry method, in the gravimetry and titometry, instruments are not useful, especially in the balance. But potentiometry method, you are using the potentiometer. Therefore, the precision is 2, so much higher. Electrogravimetry and coulometry, 0.01 to 2. Voltammetry method, here you can see approximate range. You can measure 0.003 accuracy to 10 to the power minus 10. Voltammetry method, as well as precision is 2 to 5. Very good method is a voltammetry method. When we talk about spectrophotometry method, you can see 10 to the power minus 3 to 10 to the power minus 6. And here the precision is 2. Likewise, fluorometry, again that in the fluorometry method also the absorption is involving. But compared to the spectrophotometry, fluorometry is given more precise data because with the approximate range also very high, as well as the precision also high. Atomic spectroscopy, AAS, atomic absorption spectroscopy, sometimes we call the AAS. It is having the 2 to 10 precision, as well as very high range, we can get the data. Chromatography method, again precision is 2 to 5, kinetic methods 2 to 10. Right? Likewise, the precision is ranging, but the percentage is high, percentage is high when you are using some instruments, right? And when we talk about the selectivity, okay, let's move to the next slide then see the same thing. Here I want to show you the approximate range and the method. According to the method, you can see the range will be changed. Right. So this one I also again I want to explain a little bit more about this method. So when you think about the selectivity means that if you are going to analyze sample A, compound A, if you are going to use the gravimetry method, the selectivity is poor and moderate, because in that sample maybe there is not only A is not available. Maybe sometimes B is there. In such situation, if you are going to measure the gravimetry or if you are going to get the weight, that be poor and moderate, because because not only the A, the B weight also coming. So I will give you another example. It's a moisture determination example, right? So if you want to determine the moisture content by oven drying method of the fish sample, see, now you know fish, right? These days there is a lot of talking about the fish because of the corona incidents, because corona is not there to the fish. Fish is not infected by the corona, but the people who handle fish, handling people, fishermen, so the fish handlers, I don't think that the fishermen also having corona, but fish handlers having corona, because they visit everywhere, every house to house, and that is why that they infected. And therefore people, the government asks you to, if you handle the fish, please don't touch the face and wash the fish very thoroughly, as well as wash your hands. So that is the important case. But so if you are going to handle the get the moisture content of the fish, then if you use the gravimetry method, normally we use the oven dried method, is a gravimetry method, because before you once you take the sample, you chop the sample and then you put it to the oven, right? Put it in the weighing tray and or the dish or crucible, then you put it to the oven. But you know that in the fish, once you it's a fish is very smelly product, not in the fresh situation, but later on the smell is coming out because of the ammonia, different ammonia and ammonia or the nitrogen based products, a lot of are there. Therefore those are volatiles, therefore you will get a very bad smell from the fish during the deterioration. Then that means when you put the fish to the oven, not only the moisture, but ammonia or the nitrogen based some volatile compounds also can be evaporated because of the 100 centigrade temperature, because we put it to the 100 centigrade temperature. Therefore that volatile compounds also can be gone out. Then if we are going to measure the moisture content, but we think our moisture only released, but we do not think that the volatiles also released. But in the case of volatiles also released, and therefore you will end up with normally we take the data. However, its selectivity is poor and moderate, because whatever the available ammonium nitrogen based compound also releasing. Therefore here, if we are going to use the oven drying method for measurement of the moisture content, is a selectivity is poor and moderate, because we can't select only the moisture, but whatever the other nitrogenous or volatile compounds also releasing during that method, when we dry the method, right? In the case of titometry also the same. Sometimes that we want to analyze the citric acid of the citric acid of the lemon sample, but lemon juice sample, but not only the lemon juice, not only the citric acid available in the lemon juice sample, maybe malic acid or maybe ascorbic acid or whatever the different other acids also there, right? Therefore, if we use the titometry method, that means the acid is available. You should use the sodium hydroxide titration for in the burette to titrate the acids. But they are not only the citric acid, ascorbic acid, malic acid, or whatever the acid they are, those acids also titrate by sodium hydroxide. Therefore, here the titometry method is also selectivity is poor and moderate, because you can't select citric acid only if there are other acids in the sample. Therefore, we can say it's a poor and moderate. Can you understand that? Is that example is clear regarding the explain the selectivity? Right? Is it clear for you? So I used two examples for the moisture determination of by using the gravimetry method as well as the acid determination titometry method. So those selectivity is poor and moderate, poor to moderate. Right? Seriously, not a good. But in the case of if you go for a chromatography method, you can see it is a selectivity is good, because if we use the chromatography method, you can determine only that sample, that compound. There are no other compounds you can determine, only that sample. Therefore, selectivity is a good, right? In the fluorometry method, also it's a moderate, not the poor, because some other because in the fluorometry method normally we are measure the color complexes because of the masking compounds. If the masking compounds are there, sometimes you can't get the very precious data by the fluorometry method. But compare the spectrophotometry, fluorometry also in the same situation, right? So the both we use the nanometers or the absorbance level. Now you can understand what is the selectivity, right? Then let's go to the speed. Then when we talk about the speed, in the gravimetry method, it's a slow, tritone method moderate, and potentiometry fast, and electrogravimetry slow moderate, and chromatography fast or moderate according to the sample according to the sample type. Sample type, not the sample type, according to the compound. Because sometimes that the sample will be coming out from the column for very early stage, sometimes bit later. Therefore, fast to moderate. And atomic spectroscopy is a very fast, because you measure the absorption of only that sample. So likewise, the speed can be changed. And the cost, titometry, gravimetry, potentiometry very low. But when come to the other very instrument, other methods, what we are going to use the instrument, the cost is high. And principal uses inorganic to the organic we can use, or sometimes the inorganic multi elements, organic multi component, inorganic organic enzymes, whatever the method, so you can use, right? So now you can see the methods are different. According to the method you are going to use, precision, selectivity, speed, cost, principle of the use is applying in a different way. Therefore, you have to decide these things when you decide the method for your analysis, for the sample analysis. Now, next step is obtain a representative sample, right? There are two factors we have to consider. One is the sample type, whether homogenized or heterogeneous. Homogenized means all sample are kind of it's a similar. I will explain you later what is the homogeneity, and the other one is the size of the sample. Therefore, let's see, now you want to analyze the canned fish sample coming from Chile. The container is came, then normally it's coming not a small basket or small boxes, but it's a containers come to Sri Lanka. The canned fish. So it's a dal, it's coming as a containers, right? So therefore, in that situation, so how you are going to get the representative sample? Let's see, now you are the person working in the Sri Lanka Standard Institute, Therefore, before releasing the sample from the custom, SLSI need to give some census data whether that sample is okay or not to release to our country. So let's see, now they are going to check different component. For example, what is the check normally? The parasites availability. In some in the early days that there are some talks of the parasites. Parasites can පුංචි පණුවෝ ඉන්නවා මේ can fish වල. Can fish එක ඇරියාම පණුවෝ ටික උඩ පාවෙනවා, right? So if you want to analyze this sample, then what are you going to use? Whole container, or are you going to open the can in the whole container, or are you going to take the representative sample, right? If you are going to take the representative sample, what is that representative sample? It's 100. If there is a 10,000 cans, then are you going to take the 1,000 cans, or the 100 cans, or the 10 cans, or 1 can? So likewise, so according to the sample size, you have to get the representative sample, right? And the other one is sample statistics, and the errors also we have to think here. That is when we select the representative sample. Let's say now, if there are the 10,000 cans, if we are going to take the 1 can only as a representative sample, then definitely errors will be there, because we can't predict, or we can't give the data, representative data, 10,000 can by 1 can. Therefore, at least you have to take the 50 cans or the 10 cans at least, and then from different places, and then only you can decide or you can give the report for this sample, right? Have you understood that point? Then they prepare the sample for analysis. The factors, what are the factors are there? Prepare the sample for analysis. The solid, liquid or gas. So that is very important, right? When you prepare the sample for analysis, if it is a solid, it won't be a problem. So you can handle it by using the spoon, right? If it is a liquid, then you can analyze. You can get it from the pipette, or taking a liquid, right? Pipette, right? Glass pipettes, but normally not the pipettes you are using for that's okay. Yes, because you have to know that what is the amount you are going to use, because we have done a lot of analysis experiments under the principles of food science, and also the chemistry. There you use pipette to get the liquid sample. If it is a gas sample, can you use the spoon or can you use the pipette? You can't. Therefore, for the gas sample, you have to use the different method. You have to trap the gas in a kind of a syringe, and then you have to take that sample, right? So the solid, liquid or gas, accordingly, that you have to prepare the sample. Whether the sample is dissolved or not, dissolved in water or dissolved in organic solvent. In some situation, you can't. So, for example, fats. If you are going to analyze the fat sample, you can't dissolve it in the water. If you are going to if you are going to take the lemon juice sample, you can't dissolve it is in organic solvent. Therefore, so you have to think about whether you have to use the aqueous solution, or whether you have to use the non-aqueous or the organic solution. Whether you need to ash or digest the sample. In the case of if you are going to measure the phosphorus content in the fish sample, then definitely you have to prepare first you have to make a ash, and then only dissolve that ash in the water, and then you have to analyze the sample, because you have to prepare the the oxides, and then only analyze the sample in the titration method. But if you are going to phosphorus determined by the atomic absorption spectroscopy, then you have to digest the sample and then use the digested sample to use in machine to analyze. So likewise, according to the method, you have to think about what is the way you are going to analyze the sample. You have to think about how you have to prepare this sample. Then chemical separation or masking of interferences needed. Earlier, I also mentioned that the chemical separation, sometimes you have to separate the sample out of the other thing, and the masking or inference needed. For example, let's see, now you are going to analyze the uh, linalool content in coriander. කොත්තමල්ලි කොරියන්ඩර් වල තියෙනවා ලිනලූල් කියලා කම්පවුන්ඩ් එකක්. එහෙම නැත්නම් ජෙරනියෝල් කියලා කම්පවුන්ඩ් එකක් තියෙනවා. So when you are going to roasting or කොත්තමල්ලි දැන් මේක තම්බල බොනවා තියෙන කට්ටිය නේද? So when you are prepare the coriander, so you can see that, or when you are roasting the coriander, you can see some different smell is coming, right? Yeah, whatever the inherent smell to the coriander. So if you are going to analyze that the coriander or the geraniol content or the linalool content, then you have to, sometimes these both compounds will be dissolved in the aqueous solution, but some situation it is not dissolved in the aqueous solution, then you have to go for a chemical analysis, right? So likewise, let's see, now you are going to analyze that the geraniol content, especially let's say the geraniol content in the coriander leaves. Now coriander leaves වල තියෙන geraniol content එක. But the thing is, but in the leaves you know that there are chlorophylls are there. So once you dissolve this, if you can, first you have to get the sample dissolved in the water, then you take the coriander leaves and you blend it. What will happen? All solution is becoming a green color, right? Then if you are going to do any kind of analysis, definitely then the chlorophyll will become an interference. Therefore, first of all, you have to remove the chlorophyll and get your sample out, or separate then the chlorophyll, then only you can, so let's see, now you are going to use for a spectrophotometry method, then you are going to make a color complex. Then if the chlorophylls are there, you can't make a color complex because chlorophylls are interference. Therefore, at the beginning, you have to separate sample, you have to remove the chlorophyll and you have to take the geraniol only, take out from your sample. So likewise, so the masking or interferences are there, we have to remove them first, and then only we have to take the pure sample, then only you can go for a analysis. Therefore, prepare the sample for analysis is very, very important. If it is a wet sample, sometimes you want to dry it. Likewise, then the three steps we follow. The fourth step, it says that the chemical separation or masking of interferences is needed. You have to think about that and follow that, or give that solution to that step. Need to concentrate the analyte in some situation. So if the dilution is very high, then you can't analyze the sample. In such situation, you have to concentrate the sample, analyze inside there. So rotor evaporator, likewise different methods are there. Then you have to concentrate the sample. Need to change or derivatize this analyte for detection. Sometimes you can't directly determine that compound. In such situation, you have to derivatize it. There is other compound. You make you bind that the compound A you want to measure with the compound B. What is the derivative? What is the derivatized sample? That's the mother sample, and the A is the derivatized one. A and B connected, then you take it out, and then you can measure the A only, because during the method you are going to use, then you can get only the A. I will tell you another example. Now let's see. This is a bit advanced one, but some of our research students are going to use that one in my department, some of my undergrads. That is, let's see, now you want to determine the aroma of tea. The table aroma තියෙනවනේ. Coriander වලත් aroma තියෙනවා. Likewise, the aroma of tea. Then can you but in some situation we can't determine this aroma as it is. So you can use the syringe and get the aroma gas inject chromatographic gas chromatograph filter. So you can basically you can determine the aroma compounds. But this time, actually, that student, he is whatever the available equipment, equipment is there, but syringe is not a good one. In that situation, what he is going to do is he derivatize the aroma. That aroma ටික තව compound එකකට attach කරගන්නවා, bound කරගන්නවා, bind කරලා ඒක සම්පූර්ණයෙන්ම ගිහිල්ලා inject කරපුවාම gas chromatograph එකේ අර bind කරගත්තු එක එහෙමම තියෙද්දි aroma එක විතරක් release වෙලා, so when aroma only aroma release, and it goes through the chromatography and giving the he can do the quantitative analysis. So likewise, very advanced methods are there, very interesting, but in your second year you just want to know what are the methods, that's all. So the final step is need to adjust solution conditions, pH, or add reagents. Especially in some situation, you have to adjust the pH. Right? For example, I think I have mentioned you in the protein analysis even. The protein, if you want to isolate the protein, so you have to adjust the pH, because you know that in the one pH, that particular protein will be precipitated or the coagulated. Then if that pH, if you filter the sample, then you can separate the protein, right? Therefore, if you adjust the pH, then definitely you can get the precipitated or the coagulated coagulated protein. If not so, if you change the pH, it is again dissolving the aqueous medium. So likewise, sometimes you have to add the reagents, because you know that if you want to get the calcium chloride, so if you add some if there are some chlorine, HCl, then so you can get the calcium chloride. Likewise, so you have to precipitate it, then take the precipitated sample. So I think you have done it in the chemistry classes. So therefore, need to adjust solution condition for pH or add reagents to get the precipitation, coagulation, or sometimes in that pH medium only you can measure that compound. So likewise, prepare the sample for analysis is very important. Next one is to perform any necessary chemical separations. You can follow the distillation, precipitation, solvent extraction. Solvent extraction means you can dissolve your sample in the methanol, alcohol, chloroform, hexane, likewise. Then you can take the sample out. For example, in the determination of fat content, you dissolve the fat in the petroleum ether, and then take it out from the from the sample, and then fat will be separated. Then only you can, after evaporating the petroleum ether, you can measure the fat content. There you take the weight. The other one is solid phase extraction. So that is also the advanced one. And chromatography may be done as part of the measurement step, and electrophoresis may be done as part of the measurement step. So these chromatography and electrophoresis are now available in our department, and later on once the university starts, so we will put some experiment using these machines, instruments, then you can understand what kind of methods are there. So this is the introductory section of the course module, but actually it is going to be advanced time being. But need not worry, you can understand everything, but basic idea you have to have before you start this course module. Next one is perform the measurement. So there you have to calibrate the equipment, especially in the case of pH pH measurement. Before you take the pH measurement, you have to calibrate the pH meter. And then the validation, controls, and blanks should be there. That means if you are running the example, the control sample also you have to run in the same time. Sometimes the blank sample we say. For example, in the determination of the if you are going to use the spectrophotometer, you have to adjust it by using the blank, and then you have to measure your sample. And also the replicates are very important. Keep in your mind that the replicates one. Here, I think under the statistical experimental design or whatever the step-based courses, even you may hear this thing, replicates. by analyzing one sample, you can't get the data, right? You can get the data, but it is erroneous. Therefore, you have to take at least more than 3, minimum 3, and sometimes if you can take the 4 data, then it is much better. So if you do, when you do the chemical analysis or the different analysis in your the lab practical even, basically they ask to do take 3 data. Right? ඕනම titration එකක් 3ක්වත් කරන්න කියනවා minimum to get the correct data. 3ක් කරලා 3න් එකක් then get the mean value is a really correct one, right? So don't forget that point. The replicates is very important. Try get the 3 data and get the mean value. That is very important. Perform the measurement. Therefore, replicates you have to do. You can see that the 3 volumetric flask are showing here. Titration flask are showing here. Then at least 3 data you have to take. Therefore, you have to do your experiment very quickly, analysis very quickly, and get free data. That is very important, especially in the case of food analysis experiments. Don't go for a 1 or 2 data. තුන්වෙනි එක බොරු data දාන්න ලෑස්ති වෙන්න එපා. 3ක් analysis කරන්න ඕනේ. අපි principles of food science වල if you can do take a 3, then it's much better. ගන්න පුළුවන් නම්. එහෙම නැත්නම් මේ quality assurance එකේ නම් කීයටවත් ඔයගලන්ට 3ක් data අරගෙන නැත්නම් ලකුණු දෙන්නේ නැහැ. ඒක හොඳට මතක තියාගන්න. Therefore, you have to manage your time. Experiment, especially in the practical exam or in the practical classes, even 3 data is needed. Sometimes we will ask each group take data and then the merge that one and get the 3 data කියලා. කොහමරි 3 data ගන්න කියන්න ඕනේ. Yes, sir, please follow that instruction. 3 data is very important, right? Triplicate is very important. So you have to learn it in this point. If not so, later on, sometimes the students will follow, make erroneous thing. Do the wrong thing. එහෙම එකක් වුණා මට. ඇත්තටම මගේ ස්ටුඩන්ට් කෙනෙක් come from පේරාදෙණිය. She has මම 3ක් ගත්තද කියලා, have you taken 3 data? And she said, yes madam, I have taken 3 data. And I said, I replicate කරාද? Yes madam, I have done replicate. Replicate කරාද කියලා වහම then I need not to be worried because in my university our students, they know what's a replicate. You see, then and everything she has done, finally she has done. When she analyzes the sample, පෙරදිනේ මම මගට කියලා මෙයා ට්‍රිප්ලිකේට් අරන් නැහැනේ කියලා. ඊපස්සේ මම කොහොමද නෝ she told me that she has done duplicate. No Shanghai, she hasn't done it. ඊපස්සේ බැලුවා මොකද වෙලා තියෙන්නේ කියලා. ට්‍රිප්ලිකේට් කියන එක වරද්දලා. මම දන්නේ යුනිවර්සිටි එකේ කියලා දීලා නැද්ද කියලා ට්‍රිප්ලිකේට් කියන්නේ මොකද කියලා මට ඉතින් හිතමාති මොනා කරන්නද දැන් ඩේටාත් අරන් ගිහලා ඔක්කොම ඉවරයි. So however, so she did a very good experiment and very good research. Finally, she got the best presenter award from the overall out of all students, best presenter. But the thing is, after data, then I said that it's okay now, whatever the thing, you are a best presenter, but you have to come back and finish that experiment and take a correct that point here. So likewise, so the triplicate is very important. මේක මතක තියාගන්න ඔළුවේ. ඒ නිසා triplicate කොතන ගියත් කවදා triplicate කරන්නම ඕනේ. Calculate the results and report. Statistical analysis is very important. Reliable method you have to follow, and thereby only we can get the reliability of the method, reliability of the data. We can find out by the statistical analysis. If the standard deviation is very high compared to the sample data, then that means that method is wrong or your data is wrong. Therefore, statistical analysis is very, very important. Report results with limitation and accuracy information also. Results with limitation is very much important. That means standard deviation or standard error you have to mention when you report the results, or the accuracy information you have to tell, right? So therefore, now you can understand what are the steps you have to follow when you carry out this experiment, right?
Madam, excuse me.
Yeah. Yes.
Madam, some Muslim students have to pray in between 7 to 6 p.m. 6 to 7 p.m. Then they ask for 5 to 7 minute break.
Now it's a
Uh,
6:30, 6:50.
yes, madam.
They have to pray during 6 to
6 to
7.
7 p.m.
Right.
Then
Is
they ask
are
for
you all
5 to
right?
10
Yeah.
minutes.
They okay. Right. They can leave. So until taking that break, we can have a chat. Record වෙලා නෑනේ පාරාපව. කොතෙන්ද හරි recording එක කැඩිලා. I don't know what's happened. I will check it again. Other class එකට record දුන්න නැත්නම් ආඩියෝ ඔයගලන්ට, but I think once you go through this sometimes හරි. So until they come, so if you have any question, සිංහලෙන් හරි English වලින් හරි, better to talk. බලන්න තේරෙන්නේ නැති තැනක් තියෙනවා නම් සිංහලෙන් අහන්න, but I will talk. I will answer in English. So your chat box you can use your time. හරිද? මෙතෙන්දී මේ දැන් what to do නේ. මේක කරන්න වෙන දැන් ඉන්නේ the country situation is not so good. මෙන්න හරිය නැති වගේ මට නම් පේන්නේ. So therefore you better to learn online නේ. අනිත් ළමයි ඔක්කොම රටවල online නේ කරන්නේ. One of my friend's daughter now she actually registered to the Canadian university, but they can't go because borders closed. Now Sri Lanka නෙමෙයි ආවෙනක ඉන්නේ. ඒ රටෙන් අර රටට යන්නත් බෑ, borders closed නිසා. Then she follow the online classes, and the students, most of the students follow the online classes. අපිට වැඩි වැඩි හොඳේ. ඔයගොල්ලන්ටත් මම ටිකක් වැඩ වැඩි කරනවා මේ semester එක. So basically I did not have a chance to chat with you in relation to the principles of food science. Almost all classes I have taken online from Zoom lectures, and then only the practical classes we trashed down by using 5 weeks time. Are you all right, everyone? ඔයගලන්ට ඒක අවුලක් උනේ නැද්ද? මොකද උනේ? මොකද මේ දැන් ගිය අවුරුද්ද ගිය semester කතා කරපුවා ටීමේ සරේ කතා කරන්නෙත් නෑනේ. Right. So I will explain you what is the validation test. Validation test is before you analyze the sample, so you have to validate the instrument. Basically, I mentioned you about the pH meter. Before you get the measurement from the pH meter, you have to validate it. ඒ කියන්නේ ඔයා දැන් if you need validate by using the 4 pH 4 කියන එකයි pH 7 කියන tablets තියෙනවා. ඒක ස්ටෑන්ඩඩ් ටැබ්ලට් එක 4ටමයි හදලා තියෙන්නේ 7ටමයි හදලා තියෙන්නේ. ඒතකොට මේ 4 කියන එක අපි හිතමු මේක දිය කරන්න ඕනේ 10 ml water වල 10 ml නම් වැඩි මම හිතන්නේ ඒක තියෙනවා කොච්චරද දිය ගන්න ඒ ගානේ දිය කරලා ඒ සොලියුෂන් එක අරන් pH meter එකට දාපුවාම එයා පෙන්වන්නේ අපි හිතමු පෙන්වනවා කියලා 4.5යි කියලා. ඒතකොට අපි pH meter එක වැලිඩේට් කරන එක අපව කරකවල එක 4 කියන තැන නවත්තනවා. නවත්තලා ඒක කන්ෆර්ම් කරනවා. නැත්නම් ඒකට ඒක ෆීඩ් කරනවා. ඒ වැලියු එක අපි ෆීඩ් කරනවා pH meter එකට. ඊට පස්සේ අපි 7 කියන එක අරන් එනවා. ඊට පස්සේ 7 කියන එක ඒ සොලියුෂන් එකකට ආයෙ pH meter කරක මේ නබ් එක හොඳට හොදලා මේ ඉලෙක්ට්‍රෝඩ් එක හොඳට හොදලා අපි ඒක හොඳට පිහ දාලා අපි 7 කියන එකට දානවා. දාපුවාම so when you put it in the 7 එතකොට ඒක පෙන්වන්නේ 7.3 කියලා පෙන්වනවා කියමු. Then we change it to the 7 කියන එක අපි ඔබලා හරියට වැලියු එක දීලා මේක 7.3 නෙමෙයි මේක 7 කියලා දාලා අපි ඒක අපව කන්ෆර්ම් කරනවා. ඒතකොට මැෂින් එක දැන් දන්නවා so what is the 4 and what is the 7 right? එයාට ෆීඩ් කරා එයා වැලිඩේට් කරා අපි. හතර කියන්නේ ඔයා කියන එක ඔයා ගත්ත එක නෙමෙයි. හතර කියන්නේ මෙන්න මේකයි. 7 කියන්නේ මෙන්න මේකයි. ඒතර ඒක මැෂින් එක වැලිඩේට් කරලා තියෙන. ඊට පස්සේ whatever the measurement you are going to take for a day කියන්නේ නැද්ද අපි සැලෙන්සර් වැලිඩේට් කරන්න ඕනේ. මොකද එයා වෙනස් ඉලෙක්ට්‍රෝඩ් එක අන්ඩර්ස්ටෑන්ඩ් කරගන්න එක වෙනස් වෙන්න පුළුවන්. So you have to then you can take any measurement. We call it the validation. So likewise some instrument we have to validate. අද තව එකක් තියෙනවා balance එක. balance එකත් validate කරන්න ඕනේ. දැන් balance එකේ so have you seen මේ යසාරා if you are there so when they do the ඔයාලට පුළුවන් නම් යසාරා මේ pH meter so pH meter validation and the balance validation can you take any videos so can you upload it to the LMS යසාරා කොහෙද ගිහිල්ලාද right so are you clear about that the validation so in the case of analytical balance නැත්නම් ඒකද validate කරනවා කියන්නේ so there are some weighing box weighing weights are there 0.00 0.1 sorry let's say 1 gram 2 gram 3 gram වගේ තියෙනවනේ. ඒතකොට ඒක දාලා වෙලා analytical balance එකත් adjust කරන්න ඕනේ. ඒක feed කරන්න ඕනේ. So that is the validation. එහෙම නැත්නම් ඔයගොල්ලෝ තව දැකලා තියෙනවා measure කරද්දි ඉස්සරම 0 කරන්න ඕනේ. So මේක 0 කියන එක පෙන්වන්න ඕනේ. මුකුත් නෑ ඔක්කොම පිය දාලා හොඳට clean කරලා tray එක. So we put it there in the correctly and then arrange that අර වතුර බෝලේ දැකලා තියෙනවා දැන් analytical balance එකේ. There is a bubble so you have to balance it keep it in the correct way in the tray එකේ තියලා මේ සුඩ හරියට balance කරලා balance එක කියන්නේ පිළිවෙල ඒක හරියට තියලා හෙල්ලන්නේ නැති වෙන්න then you have to put the 0 so 0 is not validate අර weight එක දාලා වෙලා ඒක validate කරන්න ඕනේ පුංචි තියෙන පුංචි පෙති වගේ මේ small weights තියෙනවා පරිස්සමට තියලා තියෙන ඒවා ඒ weight එක දාලා වෙලා මේක 0.001 මේක 0.00 කියලා ඒකට දුන්නාම analytical balance එක validate වෙනවා and also for the validation sometimes the company people come and validate the machine in that situation they use the standard whatever the not the compounds standard විදිහට ඒගොල්ලෝ validate කරනවා so validation is really important ඔබෙන් දැන් නම් pH meter එක තමයි තව analytical balance validate කරනවා thermometers වලත් thermometers නෙමේ සමහරට ඔය thermocouple එහෙම validate කරනවා ඒව adjust කරන්න පුළුවන් ආපහු oven එක validate කරනවා so in the case of oven that the temperature 40 නෙමෙයි තියෙන ඇතුලේ වෙන්නේ ඒවා එතකොට ඒගොල්ලෝ adjust කරලා validate කරනවා so those validation are really important oh calibration isn't it the calibration කියන එකම තමයි validation කියන්නේ. calibration කරනකොට ඒක ඒ විදිහට ඒක අරගොල්ලෝ ඇවිල්ලා හදනවා ඒක ඔක්කොම. තමයි validation. Yes, then madam, how can we decide the best suitable chemical test for a particular analyte? Yes, good question. And there, what we have to do is we can read many literature, chemical literature, or sometimes we have to follow the standard method. Analytical American Oil Chemist Society කියලා පොතක් තියෙනවා ලොකු පොතක් ඒක ඔක්කොම තියෙනවා sample preparation, how to validate the machine, the instrument, everything is there. And therefore, by using that method, so we can use that in relation to the whatever the instrument we have, we can select the method. So for the suitable chemical test, we can get from the literature. එහෙම නැත්නම් standard method එකකින් ගන්න පුළුවන්. Then, so whatever the method we give to you for in your these principles of food science as well as here also the under the quality assurance this food and science course, those are the chemical tests we got from the standard. Those are the standard methods we use, not prepared by ourselves. So almost all the data for the analysis we have to follow that is standard method. ගොඩක් standard method follow කරන සමහරවිට අපිම හදාගත්ත methods වෙන but those things we have to ඒ method එකත් validate කරලා තියෙනවා. කියන්නේ හරි තවත් point එක validate කරන එකේදී the other thing is you have to take the known sample. Let's say the known weight or the let's say now I'm going to analyze the caffeine content in the let's say the coffee. එතකොට මම ඉස්සෙල්ලාම කරන්නේ standard method එකක් standard graph sorry yeah standard calibration curve එකක් හදාගන්නේ. ඒකෙන් තමයි අපි ඉස්සෙල්ලා validate ඒකට අනුව තමයි ඒක validate කරලා තමයි ඒකට පස්සේ what is your sample concentration කියලා ගන්න. That is also the validation method. So accordingly we can make it. Have they come back?
Yes, madam.
Right. Any other question do you have? Method validation also we have to do as well as the calibration is a part of the method validation. First you have to calibrate it and then you can make a method validation. Method validation කරන blank sorry non sample එකක් පාවිච්චි කරන්න පුළුවන්. ඒක පාරක් කරලා එකම result එක එනවා නම් precision එක accuracy same, then we can say it's a validation. I don't know what whether Yasara is there neither. Not done Yasara miss. Calculate the results and reports. Okay. Next one is the sample size dictates what measurement techniques can be used, right? Right. මොකක් හරි රෙකෝඩ් වෙලා නැකෝ record things can be used, right? Accordingly that sample size, as I mentioned you, sometimes the sample is a very precious, then in that situation like food but if you are going to and less than 50 microliter we call is a micro. Ultra micro means less than 1 and for a liquid we can't measure the ultra micro, only the milligram, right? Therefore microliter, sometimes the symbol L but is used in the place of milliliter, right? Microliter, right? So these are the classification of analytical methods according to size and sample. How chemical analysis is applied in quality assurance and quality control. The start control system, then determine the desired state, and then go for the measure actual state. So if there is a then you go to display results. Does desired state is equal to actual? Then yes, then you can after sometimes after delaying, then you can go for a measure actual state. If it is no, then change quality control, right? Let's see what is it. Now the chemical analysis is applied in quality assurance and quality control in such situation. Now the analytical chemical analysis is very important, right? Therefore now the process is going on. Now you want to measure the sample, whether the sample of the production line in the sample. So you want to take the sample and you have to do the different analysis. And in such situation, once you do this, start the control system, determine the desired state, measure the actual state, display results, thus desired state is equal to actual, then you can go for, after some times, then you can do the same analysis again. If it is, if the desired state is not the actual one, is then the end ඕන එකයි දැන් අපේ sample එකට එන එකයි දෙකක් නම් definitely you have to go for a change the control of the quantity. එතන වෙනසක් කරන්න වෙනවා. එහෙම නැත්නම් quality assurance එක වෙන්නේ නැහැ, quality control එක වෙන්නේ නැහැ. ඒ නිසා අර දැන් quality control දැන් ඔක අහලා තියෙනවා නැත්නම් දැකලා සමහර දැකලා ඇති වීඩියෝස් වල එහෙම quality control යද්දි time to time they take the sample out. They do not check the whole sample, but they check the sample randomly and check whether that the product is tally with the desired state and the actual state. They tally desired state and what is the actual is tally. If it is tally, then they let it go. If not so, they have to check the production line. A chemical analysis system developed to maintain glucose level of a sports drink in production process. So the determine desired state, measure glucose level in a reference sample if the sample is initiated for first time or product alteration has made. If not, a written or standard value is used. Right now, here that if we are going to maintain the glucose level of sports drink in a production process, so the measure the glucose level in a reference sample. Reference sample is there for all the production lines. Then the reference sample is there or reference levels are there. So what they do is they take the sample out from the production line and check the sample whether that the glucose level is, or whatever the level or reference, whether the reference levels are there. If the reference levels are not there, then definitely they have to they have to go back to, or they have to recheck their the production line. Production line එක හරියට තියෙනවා නම් product එකේ ඒ හැම point එකේදීම reference sample එකට එන්න ඕනේ data ටිකම ඔයගලගේ actual sample එකේ තියෙන්න ඕනේ. Actual sample එකේ නැත්නම් if the same data is or same values are not there in the actual sample, that means there are something wrong in the production line. So that is why always they check it. The quality control labs are really busy in all the production companies. They work not the day and night. They work continuously. They work too, because if the production is going on continuously, definitely quality control labs are really busy. Now here in this, determine the desired state and measure the actual state. Randomly measure glucose level of product. Then display results. Measure glucose levels of product by a chemical analysis system. Then this desired state is equal actual. Like my question, that's the question. Compare the measured glucose level of products with reference value. If there is a gap, you can see desired state is like a star-like. Actual state there's a gap. Then what is the change control or the quantity? Only if measured glucose level differs from reference. If glucose in product is less than reference, then you have to add glucose. If the glucose in product is greater than the reference, then you have to reduce the glucose. For addition or dilution, you can do it. After making changes in production process, chemical analysis system should confirm glucose level has reached reference level. It was APO check equal, then we know that now the production process, the production line, the product glucose level is equal to the reference one. Then the production line can go. We can let the production line go smoothly. After sometimes again you check it. Likewise, time to time randomly you have to check the sample. Then after delay means if measured glucose level equal with reference value, make no changes. Allow the production process to run without changes. Chemical analysis system must observe production process continuously or periodically to detect any changes in glucose level. Right? So that is the thing you have to understand.